Okay, we'll see how to use the chain rule with trigonometric functions. Remember that the derivatives that we learn involving trigonometric functions are the following. The derivative of sine x is cos x. The derivative of cos x is minus sine x. And the derivative of tan x is 1 over cos square x or sec square x. Another notation for exactly the same thing is the derivative with respect to x of sine x is cos x. You need to be used with both notations. The derivative with respect to x of cos x is minus sine x. And the derivative with respect to x of tangent x equals 1 over cos square x. Let me write this time sec square x. Now, sometimes you don't find the trigonometric function itself, but it is composed with another function, with a polynomial or with another trigonometric function. And then we need to use a chain rule in order to differentiate the function given. We'll take some examples on the next slide. So let us try to differentiate with respect to x the function sine of 2x plus 1. Now, that's not sine x, but it's a composite function. It's sine u with u equals 2x plus 1. Then the chain rule tells me that if this is y, tells me that dy by dx, because we need to differentiate with respect to x, is dy by du times du by dx. So the derivative with respect to x of sine 2x plus 1 is the derivative with respect to u of the derivative with respect to u of sine u, right? So if y equals sine u, then dy by du is cos u, the formula from the previous slide. So this is going to be cos of u times du by dx. So the derivative of 2x plus 1. Doesn't matter which notation I'm using. So it's the same as the derivative of 2x plus 1 is 2 cos 2x plus 1. How about the derivative with respect to x of cos of sine x? See, it's not cos x, but it's a composite function. It's cos u with u equals sine x. Right? So if this is your function u, then dy by du is minus sine u. So the derivative with respect to x of cos sine x is the derivative with respect to u of cos u times du by dx. So the derivative of cos u is minus sine of u, or u is sine x, times the derivative of u, so minus sine of x times cos x. Now, an interesting comparison is, how about if we want to differentiate the derivative of sine of x squared versus the derivative of sine square of x? In the first case, the formula that you use is y equals sine u, where u equals x squared. Whereas in the second case, we have y equals something squared, u squared, where u equals sine x. Look how they are composed. So see, practically it's a composition between a trigonometric and a polynomial, whereas here is a composition between a polynomial and the trigonometric. They are composed in opposite order, but remember that the composition is not commutative. So u compose v is not the same as v compose u, and here is one example. So going back, how do we differentiate sine of x squared? So dy by dx, now we differentiate sine u. The derivative of sine u is cos u times the derivative of u. Generally I put a polynomial in front, so it's 2x cos x squared. How about the second case? The derivative of u squared, so dy by dx. The derivative of u squared is 2u times the derivative of u. So 2 sine x cos x. Sometimes it's required to apply the chain rule more than once. So then you need to show all the steps in order to make sure you don't make mistakes. Let us take an example. Y equals sine of 1 minus 5x to the power of 7. So see, it is different from y equals sine to the power of 7, 1 minus 5x. Let's actually do both of them. So in the first case, dy by dx, the formula that uses sine u, yes, where this one is your u. The derivative of sine u is cos of u times the derivative of u. And now here, in order to find the last derivative, we need to apply again the chain rule. So I'm going to start with this one. Chain rule. U to the power of 7